Hello YouTube, this is Eli, the OBD Tech. I'm here working on a 2005 Dodge Ram 1500 with the 5.7 Hemi engine. The vehicle came in with the check engine light, and also the customer's complaint was that that the vehicle tends to have a rough idle, and he also explained that during driving, the vehicle either tends to want to shut down or actually shuts down, but the car does restart once the car shuts down. So I have my scans already hooked on. Um, we have actually one permanent code. I'm gonna show you guys. It's basically the P0404. That's the EGR Position Sensor Performance Rationality. This code P0403 and code P0406, those were actually created by disconnecting the connector on the EGR. But the code that this car came with at first, it came in with the P0404. So that's our main code to focus on this diagnosis, this P0404. Basically, what it's telling us at the EGR position sensor performance is that the computer is detecting that the EGR is not closing all the way. It's probably stuck partially open. So this problem could actually cause this vehicle to have this rough idle, and it could also cause the vehicle to actually shut down due to excessive EGR flow into the intake manifold. In other words, it's considered to be like a vacuum leak. So that's why this car tends to either want to idle very low, or even it shuts down. So the next thing is to look at the wire diagram to see how this EGR system is being controlled. Alrighty guys. Alright guys, so this is our EGR valve assembly wiring diagram. This EGR has 5 pins. Basically pin 3 is our sensor ground, which is a dark blue with dark green. Our pin 1, that's our EGR signal, that is dark blue with light green. And our pin 2, that's a yellow pink, that's our 5-volt supply. And then pin 5, that's our EGR solenoid control. And finally pin 4, that's our ground wire, which is black with white. Alright, so the way this EGR solenoid is being controlled, just by looking at the diagram, this is a power side switch EGR solenoid. The way I know that is just by looking at the wire that doesn't go to the computer, which is our ground wire, which is pin 4. Our ground wire is it is externally sourced. So the way solenoid works, it has to have a power and a ground. So it means our power is coming from the computer, so which makes it a power side switch. It means with the key on, engine off, or with the engine running, without the EGR being activated, both pin 5 and pin 4, our voltage rating should be approximately 0 volts. But once the computer commands the EGR to actually be activated, our pin 5, our voltage should actually jump to approximately 12 volts. That's with the activated solenoid. But just with the key on, engine off, or with the engine running without the EGR being activated, both pins 5 and 4, our voltage should be approximately 0 volts. With the EGR activated, pin 5 should be 12, and our pin 4 should be approximately 0 volts. Alright guys, so let's go out there and perform our voltage checks on these 5 wires. Alright, so I'm here already set up with my voltmeter. I'm actually back probing our EGR signal. It is pin 1, dark blue with light green. So currently our voltmeter is showing approximately 5.55. But one thing that I noticed while back probing the signal is that our voltage was actually fluctuating as I was moving the connector. As you can see, our signal tends to fluctuate up and down. So maybe I'm thinking that our problem maybe lies with the faulty signal on the sensor side of the EGR. So it's not a harness issue. It's actually the EGR on the signal terminal that's probably faulty. Because as I said, as I wiggle the EGR housing here by the connector, as I move it, our voltage fluctuates. So this could be a potential problem here. Instead of a maybe a partially stuck open pinto on the EGR valve. But let's continue doing our voltage checks. The next wire I'm going to perform, it's going to be pin 2. That's yellow with pink, and that's our 5-volt supply. So I'm going to move the T-pin next to the yellow wire here. I'm going to back probe it, and that should be approximately 5 volts. As you can see, it's 4.98, which is good. Next wire I'm going to back probe, it is our sensor ground, which is pin 3, dark blue with dark green, which is the next wire next to the yellow one. I'm going to back probe it. And that should be approximately 0 volts, less than 0.1. As you can see, it's showing approximately 0 volts, which is good. So the next wire I'm going to back probe is the pin 5, which is our control wire. Remember, this is a power side switch. With the key on engine off, our voltage should be approximately 0 volts. So I'm going to back probe that dark blue with violet wire, which is below this wire here. So I'm going to back probe it, and it should be approximately 0 volts with the key on engine off. As you can see, this is basically approximately 0 volts. This is a power side switch. Both the control wire and the ground wire should be 0 and 0 with the key on engine off, without the cylinder being activated. So next thing I'm going to back probe is our ground wire, which is our pin 4, black with white, which is on this side, on below the RR, especially below the our EGR signal wire. It's a black with white, and that should also be with key on engine off, approximately 0 volts. As you can see, it's also showing 0 volts. It's probably not making a good contact. Alright, so here you go. It's also showing 0 volts. This is, remember, power side switch, and that's normal. Both wires should read 0 volts without the EGR being activated. But once the EGR is activated, our control wire should actually go from 0 volts to some type of voltage. It's not going to be approximately 12 volts because the control wire is being controlled by the computer. It is a duty cycled. So depending on the duty cycle of the computer being commanded, our voltage should jump anywhere. It should just jump anywhere from 5 volts and up. But so far this is showing up good. But my only concern is our EGR signal. How I was wiggling the housing on the EGR and our voltage was fluctuating. So that could be a potential problem here. But before condemning a potential sensor side of the EGR, I will also remove the EGR and perform a visual inspection just to look at the EGR pintle to see if it's maybe stuck partially open due to carbon buildup. So the next thing I'm going to do, I'm going to back probe our control wire and use the scan tool and do some bidirectional control. And let's watch our control wire while being duty cycled. Alright guys, so my scan tool is already hooked up. I'm ready to perform some bidirectional control with my scan tool. I'm going to perform a duty cycle on the control wire. It's set at 15 seconds. A duty cycle is at 50%. So 50% is the highest, a duty cycle, that my scan tool allows me to perform. So remember, on a power side switch, our voltage with the key on, engine off, it should be approximately 0 volts. But once the EGR is activated, our voltage should climb. Since the computer controls our control wire and is pulse width modulated, our voltage will fluctuate depending on the duty cycle. So at 50%, our voltage should jump. So let's watch our voltage on our voltmeter here. So with the key on, engine off, it's showing approximately 0 volts. I'm gonna hit start, and let's watch our voltage. Remember, it's a power side switch. So at 50% duty cycle, our voltage should climb to approximately 5.46, 47. So remember, so the higher the duty cycle, the higher, the voltage. But since my scan tool only allows me to go perform a 50% duty cycle, our voltage climbed up to 5.47. So our 50 seconds is up. It's back to 0 volts. So that shows that our control wire is in good condition. There's no shorts or opens. I guess the next thing I'm gonna do, I'm gonna back probe the signal wire on the EGR, and let's watch the signal. All right, guys. So this is what the signal being back probed on the EGR signal. Like I said, it's currently showing about 5.54. So the next thing I'm gonna do, like I said, perform this duty cycle again at 50%, and let's watch our signal. So here we go. So at 50%, our signal dropped to about 0.46, 0.47. So like I said, for the EGR signal, I guess the higher the duty cycle, the lower the EGR signal. I'm not sure what's the specs for this vehicle on the EGR signal, but let's keep in mind about that EGR signal, which was around 0.58 as our current spec for this vehicle right now. So I guess the next thing I'm going to do is just remove the EGR valve and see if our EGR valve has maybe some potential carbon buildup on our pintle. Alright, guys. Alright, so for those that don't have a scan tool, with bidirectional control capabilities, you could actually perform an EGR function test by using a 12-volt battery test light and touching the control wire on and off, either with the key on, engine off, or with the vehicle running. But make sure that when you perform this test, to make sure to know the circuit design on the control wire of the EGR solenoid. In this case, this vehicle is a power side switch. It means our test light will be connected to our positive battery post, which is connected already. Since it's a power side switch, if it was a ground side switch, then our test light would have been connected to the negative battery post. So that's very important, guys, to know the circuit design, because if you don't, and you perform this manual function on the EGR, you could actually cause damage to the driver on the PCM, and that's going to cost you more money to actually fix. So in this case, like I said, this is a power side switch. My test light is connected to battery positive. I have already my T-pin connected to our EGR signal. So next thing, I'm gonna put the key on, engine off, and then perform this test. All right, guys. So with key on, engine off, I'm gonna touch the control wire on and off, and this is gonna basically we're actually performing an EGR function test, and to see if our EGR solenoid is clicking. So here we go. I'm gonna hit it on and off and see if my camera could pick up the clicking. So on and off. Even my light is being turned on. So you can see our EGR solenoid, it is clicking, so that means, you know, that's a good indication. Next thing I'm going to do is with the vehicle running and perform this test. So let me set up and then show you guys this. Alright guys, you know, so this is the next test. It's called the EGR Function Test with the vehicle running. I'm going to perform this on and off test light on the control wire. By doing this, our vehicle will either run rough or even stall. If that happens, it means that our EGR system doesn't have any restrictions on carbon buildup. So I'm going to go ahead and perform this test. I'm going to touch the control wire on and off. I do hear the solenoid clicking, but I think our test light is not strong enough. It's not carrying enough voltage to actually perform this EGR function test with the vehicle running, which kind of sucks. So I guess, you know, I can't use the test light to perform this EGR function test with the vehicle running. So instead, you know, I'm going to use a neat tool that I have. It's a EGR tester, which I have over here. So in this case, you know, this tester will actually test the EGR valve by, you know, just by hooking up the harness connector, which is right here, to the EGR, and I will actually control the EGR manually, but, you know, just by pressing on this button, which is on the solenoid 1. You know, so that's going to actually perform our EGR function, which is going to either make our vehicle run rough or even stall. So let me set up and then show you guys this test. Alright guys, you know, since our test light did not work for the EGR function test with the vehicle running, I'm using the EGR tester, the Weekon model number 47080. So in this case, you know, I will perform the EGR function test by pressing on this button. By pressing this button, our vehicle is either going to run rough or even stall. If that happens, it means that our system doesn't have any restriction on carbon buildup. So this is the kit that I have. It has a harness and also like the harness adapter for, you know, for this EGR valve. So for every vehicle, you know, there's a special adapter. This is a C1 adapter for Chrysler. So I'm gonna go ahead and press the button, and let's watch our vehicle. It's either gonna run rough or even stall. Right there, our engine did kind of stumble. That's like I said, it stumbled again. And this time our vehicle actually shut down. So that's well, you know, that shows us that the system does not have any restrictions. So I guess, you know, we're done with doing our EGR function tests and voltage checks. The next thing was to do a visual inspection, and let's watch for any carbon buildup on the pintle to see if it is partially open, which is causing this symptom for this customer, that the vehicle either runs really rough or even shuts down at moments. Alright guys, you know, so this is what the EGR valve already removed from the vehicle. The EGR valve does not have any carbon buildup on both sides of these holes on the EGR valve. It's pretty much in still in good condition. Both of them look clean still. I don't know, you know, if the camera's picking up the inside of the pintle, but the one thing, you know, I did notice, guys, and which I also noticed earlier during our voltage checks, especially on the EGR signal, how our voltage was fluctuating as I was wiggling the connector here on the housing. So by using this special tool, I was actually able to find the glitch just by using this tool here. That as I wiggle the connector, here, as I try to push in the connector into the housing connection, watch our feedback sensor voltage there, and watch how it tends to glitch. You see how our voltage glitches as I move the connector. As I push it further in, our voltage, our feedback actually goes away. So this vehicle does have like a glitch. It is a bad feedback EGR signal. It's basically the damage is inside the housing. So in other words, this EGR valve will have to get replaced, because since the EGR valve is giving a false signal back to the computer, it's making the vehicle is making the EGR, the computer activate the EGR at moments where the EGR does not need to be activated. So it causes the vehicle to either run rough or stall. So it's basically, like I said, a faulty pin on the EGR signal. Like I said, as I wiggle it like this, that's how we our contacts tend to show up with the glitch. Let me try to perform this one more time, guys, just to... Oh, it doesn't want to do it. There you go. Our feedback voltage currently showing about 1 volt. As I wiggle it, it goes away. So basically, it's a faulty EGR signal on the housing. So thanks for watching, guys. Subscribe if you like. Alright, guys, so I'm here to show you guys the final fix. I got the new EGR valve. It's a Duralast brand. So I'm going to use this special tool. This special tool. As soon as I push in the connector on the EGR, our voltage should climb to about 3.5 volts. That's the spec for this vehicle, and this EGR should be around 3.5 volts with the key on, engine off. Alright, so I'm gonna go ahead and push the connector. It's in. Our voltage went all the way to 3.5. That's, like I said, that's the spec for this vehicle. Now the next step, I'm gonna press the solenoid 1 button. When I press the button, our voltage should drop to about 0, and then as I let go, it should go back to 3.5. So here we go. So this is a good working EGR valve. Compared to the our defective EGR valve signal that was actually making faulty contact. The problem with this EGR valve is the internals on the EGR signal. So this is a final fix on this vehicle. So thanks for watching. Subscribe if you like.